Chemistry, Chapter 22, Theory Video 5. So the effect of temperature on the rate constant. So obviously you know that when the temperature is increased, there would be greater number of molecules having energy greater than the activation energy. So as a result, the rate of the reaction increases. That is something that you already know. So if the rate of the reaction increases, the rate constant needs to increase. Therefore, because of the higher rate constant only, the rate of the reaction is higher. So as a result, the rate constant and also the rate of the reaction is proportional to the fraction of the molecules having energy equal to or greater than the activation energy. So we obviously understand that the rate increases as temperature increases. As a result, the rate constant also increases as the temperature increases. So now what we are going to do is we are going to try and understand how the temperature affects the rate of a reaction. It is commonly proven that every 10 degrees Celsius rise in temperature, the rate of the reaction approximately doubles. There is an equation that gives us this relationship. It is ln k is equal to ln a minus ea upon rt. So natural logarithm of k is equal to natural logarithm of a minus ea upon rt. K is the natural logarithm of the rate constant. Then a is a constant related to the frequency of collisions and the orientation in which the molecules collide. So you will have to remember it as it is. Then Ea is the activation energy, R is the gas constant, T is the temperature in Kelvin. So if you know these details, you can carry out, you can understand, you can calculate K. However, they are saying that you do not have to learn this equation, so you don't have to. So don't try to remember this, but it will help you to understand how temperature affects the rate constant. So that means you are not going to get questions based on this equation, this particular equation only, to do calculations. So this A, that is the constant that they have given. A doesn't change with temperature that much. So we say that we assume that it is a constant. E, A and R also are constants. You know that. So the graph of natural logarithm of k against 1 upon t would give a straight line of gradient negative Ea upon R. So this is something that you have to understand from this figure. So if the rate of the reaction increases with temperature, that is what is given from the first graph. Then so the second one gives you natural logarithm of k against 1 upon t, that will give you a straight line. So this shows that the temperature, with temperature, how the rate of the reaction increases. Write down a note. The rate of a reaction increases with higher temperatures because there is a greater proportion of molecules having energy greater than the activation energy. Leave a line, put a star and write down. With every 10 degrees Celsius rise in temperature, the rate of reaction approximately doubles. You don't have to know the equation, so I'm not going to give you a note on that. But you would better draw these two graphs. if you won't, that is, even if you don't draw that, it is not, it is really, and actually so far it has not been questioned upon, but try to understand it, try to memorize the graphs, how it is going to be. Now we are going to figure out the order of reaction from raw data. So earlier we had all of the data and details, the information that has been given to us. So now we are going to find out how to use the raw data or the initial data to get the order of a reaction, to understand the order of a reaction. So if we have a reaction that is going on its way, if we know the initial concentrations of the reactants, and if we follow through the reaction to until its completion, we can figure out what concentrations of reactants are going to be left at the end. And during the time it progresses also, we can take samples and figure out what the amount of reactants present in it. Then what we do is we plot a graph to show how the concentrations of this particular reactant or the product, you can take both, either way, as we discussed at the beginning of this lesson, and how it changes with time. Then you take tangents at various points along the curve corresponding to the particular concentration of the reactant, and then using the gradient we calculate the rate reaction from the slope of the graph. Then we plot the graph of rate of reaction against concentration, and from there on out you know what to do. So then there is another method called using initial rates. The course of that is what we just discussed was using the data from the course of a reaction. Then using initial rates is another method that we can follow. It is used if the reaction rate is very slow. What we do is we carry out several experiments with different known initial concentrations of each reactant. Then we measure the initial rates of reaction by taking the tangent of the curve at start of each experiment, or measuring the concentrations of a reactant or product soon after the experiment has started. Then what we do is, for each reactant, we plot a graph of initial rate against concentration of that particular reactant, and that will give us the details that we need. Now let's look at this worked example. If you didn't understand how these things are done, then this will give you the basic idea as to how this is going to be done. So nitrogen 5 oxide N2O5 decomposes to nitrogen 4 oxide and oxygen, 2N2O5 gas, giving you 4NO2 gas plus oxygen. So they have given the initial rate of reaction, how it changes with initial concentration of N2O5. So they have given on the left hand side initial concentration of N2O5, then the initial rate has been given on the other side. If the concentration is 3, then the initial rate is 3.15, and then it is 1.50, the initial rate has dropped by half, 1.55. Then when the initial concentration has dropped from 1.5 to 0.75, then more or less initial rate has decreased by half as well to 0.80. So this shows us that the initial rate of the reaction is directly proportional to the initial concentration of N2O5, because only N2O5 is there, and it is 1-to-1 reduction. As a result, we can figure out we can draw the initial rate again initial concentration, and that gives us a straight line so that we understand directly proportionality of the initial concentration against the rate. So you can do question number 8, but before that let's go through this question 5 and write the note also. The question 5, the equation below describes the reaction of propanone with iodine. Hydrogen ions catalyze this reaction. CH3COCH3 plus iodine, then hydrogen ion catalyzes it to produce CH3COCH2I plus HI. So using a colorimeter, this is being followed. So that is a progressive uh, progressive using the during the course of a reaction. Looking at the progress is what we have used here. This progression following method is used to is done by using a colorimeter. So the brown color of the iodine fades as the reaction proceeds. So the experiment results would be given by this table. So what has happened is HCl for the you can see that the it is reacted with CH3COCH3 in the presence of H plus. Then you have propanone and iodine. Propanone initially 0.50 in the first experiment 0.50, then HCl is 1.25, iodine also 1.25, initial rate is 10.9. Then HCl is dropped to 0.625, that is half of what we had earlier. Then propanone is the same, iodine is also the same, initial rate has dropped by half to 5.4. Then we change the HCl is remaining same 1.25, but we have dropped propanone to 0.25, so that means propanone concentration has been reduced. Then the initial rate also has been obtained to be 5.1, so that means the initial rate is dependent on the propanone concentration as well. So HCl is also important. Then propanone is also important. Now what we do is we maintain HCl and propanone at the same level, 1.25 and 0.5 each, but we reduce the iodine by half, 0.625. Nothing happens to the rate remains constant at high value 10.7. So that means it is not dependent on iodine. So this is real experiments. There would be experimental error, so that is the reason why 10.9, and there's a difference between 10.9 and 10.7 and 5.4 and 5.1, but 10.9 is not going to be 5.4, so that is not an error. So 5.4 and 5.1 could be taken as they are similar to similar values, and 10.9 and 10.7 can be taken as similar values. So the hydrogen ions have come from the hydrochloric acid. So we see that changing concentrations of each reactant have effects, and we discussed that. We just discussed how it happens. So as a result, we know the reaction is zero order for iodine because it has no relationship that with the there is no effect on the rate of the reaction for iodine. So that means for propanone, when you double the concentration, the rate of the reaction also doubles. So that is from 0.25 to 0.5. When you double it, the rate of the reaction doubles. So that means for propanone, it is the first order. Then for H plus, from HCl, it is again first order, because when you double the HCl concentration also, the rate of the reaction doubles. I hope you understood. You will have to do question 9 and 10, 8, 9 and 10. But before that, let's write down a note. Deducing order of a reaction from raw data. To determine the order of a reaction, we can either use data from the progression or the course of a reaction, or during the course of a reaction, or by using the initial rates. If we take data from the course of a reaction, we follow through the experiment until it's complete or close to completion. Plot a graph to show how the concentration of a particular reactant or product changes with time, using tangents drawn calculate the rate of the reaction and plot a graph of rate of the reaction against concentration. From that you can calculate you can actually find out the uh, order of the reaction. Then using initial rates, several experiments are carried out with varying concentrations and measuring the initial rates. Then plotting a graph of initial rate against concentration of the particular reactant will help us measure and understand the order of the reaction. So I hope you understood. If you didn't, please ask questions. If you did, please do question number 9 and 10. I hope you understood this worked example the way I explained it to you. If you did not understand, please tell me, then I will explain it further.